All right, guys, so today we are on, where are we, 5.6. So we're talking about the area of a region between two curves. So a lot of this is going to be using integrals like what we did before, but instead of just finding the area under one curve, we have a second curve, and we want to find the area in between the two curves. So instead of a curve and the x-axis, we are looking for the area between a curve and another curve. So this first example gives us y equals x squared, which is this curve right here. I'm going to actually, it's this blue one. And y equals root x, which is this red curve right here. And it wants us to find the area between those two curves. So one way to do this is kind of something that we've done in the past, and that's just finding area, right? One way to do this is you find the area under the big curve, which is what they did right here. Then you find the area under the little curve, so you'd find the area under the lower curve, which is what they did right here. And then you just subtract one from the other, right? If you take the big area and you subtract this part that we don't care about, you end up with the area that's left over, which is that middle piece. Now, the way that we do this in calculus, what we're going to do, we're actually going to use integrals, okay? We're going to take the integral of the top function, and in this case, my top function is my root x, and then we're going to subtract the bottom function, which is x squared. Okay, we're going to take the integral from the top function minus the bottom function. Now, the only thing that we need to figure out is what our limits are, okay? What limits we're integrating between. If it doesn't tell you, in this one, it kind of shows you on the graph, it gives you an idea that we're probably integrating between 0 and 1. If it doesn't tell you, what you're looking for is where these two functions are going to cross, where they equal each other. So in this case, I would take x squared, I would set that equal to root x, and then I would solve for x, right? I'd square both sides, and then I'd get x to the fourth minus x equals 0. Factor out an x equals 0. That means x equals 0, or x is going to equal, what, positive 1? Because 1 minus 1 is 0. So those give me my limit. So if it doesn't tell you, if it doesn't show you where those intersections are, you just set them equal to each other and you find where our functions cross. And that's going to give you the limits of integration. From there, most of these questions, they're usually calculator questions. We'll do a couple of them by hand, at least part way through. I don't think we'll work all the way through them. But in this case, I would just plug this in my calculator. Like I said, that's kind of the most common. So I'm doing a definite integral. I'm going from 0 to 1, and it's of root x. So I'm going to do root x. And then on the outside, I'm going to minus x squared. And that gives me 0.33333, which, if you look at what their values were, the areas of the curve, they would have gotten the same answer, okay? So, moving on to some more interesting problems. It asks me to find the area bounded by f of x equals 2 minus x squared and g of x equals negative x. Now, if whatever work you're doing in the calculator, a lot of this you can do in the calculator on the calculator questions. You just have to make sure that you write down what you're putting in the calculator. Okay, so as we go through this, there are some things that we're going to have to figure out and write down, but once you know what you're solving, you can put it in the calculator to get the answer. All right, so first things first, I know that I need an integral, and I need an integral with bounds, and I need to figure out the top and the bottom curve. Okay, so the first thing I'm going to do before I worry about which one's on top, which one's on bottom, Let's set them equal to each other to figure out my endpoint. So if I do 2 minus x squared is equal to negative x, then I'm going to move these to the right side so they stay positive. So 0 equals x squared minus x plus 2. Nope, not plus 2. Bad math. X squared minus x minus 2, which means when I factor, I'm going to end up with an x minus 2 and an x plus 1, which means that my x's are 2 and negative 1. Okay, I'm not going to go through that any slower. We've been doing that for a couple of years now. So I know that I'm integrating from negative 1 to 2. Now I've just got to figure out which curve is the top curve and which curve is the bottom. One way would be to graph them. If this was a graphing question, you could put it in the graph and just see which one goes where. But if I look at these, my f of x, 2 minus x squared, the 2 is a vertical shift. So that means it's shifted up 2, and the minus x squared means it's an upside down parabola. G of x equals negative x. Well, that's just like saying x equals y, but instead of a positive x, it's the negative. So instead of my line going up to the right like this, like it would if we had y equals x, we have y equals negative x, so my line's going the other way, okay? So here's my intersections, and I'm looking for this area right here in the middle. So my top curve, the one that is on top, is my f of x. My bottom curve is my g of x. So that means that my integral is going to go from 2 minus x squared, that's my f of x, minus my g of x, which is negative x. So really I'm integrating from negative 1 to 2 of 2 minus x squared plus x dx. Now, if you were doing this on the AP test, you are going to get a point right here for finding the endpoints, for finding your limits of integration, okay? You are also going to get a point for this part, writing down the actual integral. From there, you're going to get one more point, most likely, for the answer. And if this was a calculator question, since I've written down what I'm putting in the calculator, I can just put this function, this whole thing can go right in the calculator and I can get an answer. If I was doing this by hand, if it wasn't a calculator question, I would have to actually take the integral. So I would integrate the 2, which just becomes 2x. The negative x squared becomes what? Negative 1/3 x cubed. And the positive x becomes an x squared, but I need a 1/2 in front of it. And I'm integrating from, I lost my pen, I'm integrating from negative 1 to 2. So this is a big, ugly problem if you're doing it by hand, because you've got to plug in the 2, right? So I've got to do 2 times 2 minus 1/3 times 2 cubed plus 1/2 times 2 squared. And then I've got a minus plugging in the negative 1 to everything. So 2 times negative 1 minus 1/3 times negative 1 to the 3rd power plus 1/2 times negative 1 squared. I'm not going to worry about that because, like I said, these are usually calculator questions. So I'm going to do the 2 minus x squared plus x. I'm going to go math. I'm doing an integral. And I'm going from, what did we decide? Negative 1 to 2. And my integral, I'm doing x. No, I'm not. I'm doing, now I forgot what it was. 2 minus x squared plus x. So 2 minus x squared plus x, and it gives me 4.5. Okay, so again, if this was a calculator question, there's 1 point, there's another point, and here's your 3rd point for getting the right answer, as long as they're actually correct, of course. Okay, find the area of one of the regions. I like this question. One of the regions bounded by f of x equals sine of x, and g of x equals cosine of x. So if I were to draw this, okay, I know some of us don't have as much experience drawing sine and cosine curves. But if I were to draw this, remember, sine are my y values, right? And if I think about the unit circle, when I start at 0, my y value is 0, okay? So my sine function starts at 0, 0, and it goes up and comes down and goes up and comes down, and it just continues that pattern, right? Now my cosine, those are my x values. So when x is 0, or excuse me, when my angle is 0, my cosine, when I start, my cosine at 0 is 1. So my cosine value starts up at 1, and it kind of follows the same pattern. It just follows, it's a little bit ahead of my other graph. So what it's asking us to find, it's asking us to find the area between two of these curves, okay? Now, in this case, my sine of x is on top. My cosine of x is the one on the bottom. But I need to know where do I start and when do I end? I know that I'm going from sine of x on top, and I'm going to minus cosine x on the bottom. But I need to know where do I start and where do I end. So if I look at my unit circle, I'm interested in when does sine of x equal cosine of x. And again, we're not going to use the entire unit circle. We're just looking at the first part of our unit circle, okay? So sine of x equals cosine of x at pi fourths, right? And then also it's going to be at 5 pi fourths. Okay, in my domain right there, I go pi fourths and 5 pi fourths. So down here, I'm going to put pi fourths on the bottom, and I'm going to put 5 pi fourths on top. And then, of course, we've got our dx. So I'm going to get a point right there for getting my limits. I'm going to get another point for setting up my integral. And then my third point is going to come from my answer. All right, so if this is a calculator question, I just plug it right into the calculator. So I go math, integrate. I'm going from pi fourths, so pi fourths, and I'm going up to 5 pi fourths. And then I did sine of x minus cosine x. So I plug it in my calculator, hit enter, and I get 2.828. So my answer is going to be approximately 2.82, what was our rounding? 2.8284, so 2.828 would be a good answer, okay? If this was a free response question without a calculator, okay, so let's say I can't use the calculator, I have to actually do the integral. So when I do the integral of sine of x, I get negative cosine x. And when I do the integral of negative cosine x, I get negative sine of x. But then I'm evaluating from pi fourths up to 5 pi fourths. Okay. Now, if this is the free response, I don't have to do any more than write down my next step, right? I can plug in my value, so I'm going to get negative cosine of 5 pi fourths minus sine of 5 pi fourths minus negative cosine of pi fourths minus sine of pi fourths. And if this is the free response, I stop right there. Okay. If it's multiple choice, you might have to actually find these values. So for example, cosine of 5 pi fourths is negative root 2 over 2, but there's a negative in front, right? And then I've got another minus sine of pi fourths is also negative root 2 over 2. Where did my buttons go? There we go, negative root 2 over 2. And then I'm going to minus negative cosine of pi fourths. That's going to become negative root 2 over 2. And I'm going to minus sine of pi fourths, which is root 2 over 2. And then you would keep going. Okay, you're going to combine everything. You're going to put, wait a minute. One of those isn't right. Which one is it? Because that's going to add up to be 0. And it shouldn't add up to be 0. It should add up to be... Which one is it going to be? No, we'll be all right. We'll be all right because we're minusing a minus. There we go. That's what I'm missing. We've got 2 negatives here. So actually what I end up getting is, what, 2 root 2 over 2 plus 2 root 2 over 2. So I end up with root 2 plus root 2, which root 2 is 1.414. So that makes sense that I'm at about 2.828. There we go. That looks better. I was thinking those were going to cancel each other out, but we've got the double negative. So depending on the question, you might have been done clear back here, okay? You might have finished clear back when you plugged it in the calculator. If it's a free response, you would have had to go one more step, right? You would have had to write this out at least. And if it was multiple choice, you might be going all the way down to here by hand. Just depends on which version you were lucky enough to get on the test. Okay, find the area of the region between the graphs. Now looking at this, at what it's giving us, I wouldn't imagine this is one that they're going to give you to do by hand. Okay, this is probably going to be a calculator allowed question. So when it gives me these pictures, 6x cubed minus 2x squared minus 20x, I have no idea what that's going to look like. But I can graph it. I can go to my calculator. I can go to y equals, and I can plug in 6x cubed. And then we had minus 2x squared minus 20x, I think. And when I graph that, this is what it looks like, okay? Which, with the x cubed, that might have been a hint that it's going to look something like that one. But then I also have to graph my other one. Let's see what was our other one. Negative 2x squared plus 4x. Let's graph that one as well. So let's graph negative 2x squared plus 4x. So that one's going to be graphed in black. So when I graph it, this is what I see, okay? And this one's a little bit trickier. It wants to find the area of the region between the two graphs. All right, now we've got a lot of different things going on right here, okay? In fact, these cross in 3 different places, right? Well, one of them you can't quite see, so let's zoom. No, it lets me zoom in, but it doesn't let me zoom out. Okay, so let's zoom out just a little bit. And then I can zoom in on my own. Zoom out. Zoom out, please. Zoom out again. Come on. There we go. All right, so I've got 3 places that I intersect. I intersect right down here on the left, and I intersect right at the origin, and then I'm intersecting over here to the right as well. Now, here's what we need to be careful of, is if you notice on the left of the origin, my blue graph is on top. But on the right side of the origin, the blue graph becomes the bottom graph, okay? So I'm going to have to set up 2 different integrals, because for one of my integrals, the top function is 1, and it switches on the other function. So if this was me and I was able to use my calculator, I would use my calculator to find the intersections. I'm not going to set up that f of x equals g of x with an x cubed and try to solve when those are equal to each other. I'm going to use my calculator, and I'm going to go to second calculate, and I'm going to go to intersection. and I'm going to just get close to my two intersections. So one of them is right here, and it tells me that where did we go? What just happened? Second, calculate. This is so different than doing it on your guys's. Left bound. So I'm going to go to the left of my intersection. There we go. That's what happened. If I go to the left, I go to the right, and it tells me I'm intersecting. My value is x at -2. Okay. So one of my values is -2. The other one is 0. That one right there at the origin. I'm not even going to find that one. My other intersection is at the origin, and then I'm guessing that my last intersection is going to be at +2. So let's double check and make sure, and it is. It's at 1.9999999, so we can say that that's at +2. So those are my three intersections, but when I go from -2 to 0, that blue graph is the graph on top, okay? My blue graph is my top graph. So 6x cubed minus 2x squared minus 20x is going to come first. Then I'm going to minus -2x squared plus 4x. That's one of my integrals, okay? But that's only half of the area between the curve. Well, not exactly half. That's only part of the area between the curve. That's this stuff on the left. I also need to add the stuff on the right. So to that integral, and I should have written this a little bit smaller, I'm going to add the integral from 0 to 2, but I'm going to switch my graphs. I'm going to put the -2x squared on top plus 4x. That's my top curve. And then I'm going to minus the 6x cubed minus 2x squared minus 20x. And then, of course, we've got, don't forget our dx's there. Okay, so when I do a little simplifying here, let's see, -2 to 0, 6x cubed, this negative distributes, right? So this becomes a plus 2x squared. So I get 6x cubed, the 2x squared minus 2x squared cancels, and then I have minus 20x, but this becomes a -4x, so that becomes minus 24x. And then I'm going to add the integral from 0 to 2. I get -6x cubed when I distribute this negative to everything. And then I've got positive 2x squared and a -2x squared. So again, those are going to cancel out. But then I get 4x minus, nope, I get 4x plus 20x because that negative distributes. So I get 24x dx. Now, if this was the calculator question that I think it is, you are going to get a point for this one, for getting your limits. You are getting a point for setting up this integral. And you're also going to get a point for the answer, all right? So on your calculator, you can type in the 6x cubed minus 24x. So I can go back to my home screen and I can do math, integrate. Now let's see, I'm going from -2 to 0. And I've got 6x cubed minus 16x. Is that what we had? No, it's minus 24x. That's not right. Minus 24x. And then I'm going to add the integral, math integral from 0 to 2 of my other half, which was -6x cubed plus 24x. And I get 48, okay? If you go back to what we did, if I'm looking at this, if this was a free response question, I wouldn't have even needed to type, whoops, let's not do that. If this was free response, this part right here is a step further than I would have needed to go. I could have left it like this, which would have been a headache to put in my calculator. Putting that big, ugly mess in my calculator wouldn't be very fun. But we can actually use the fact that, remember up here when we set up our graphs, we said that y1 is equal to 6x cubed minus 2x squared minus 20x. Well, back here when I do my integral, just a calculator shortcut you guys might be interested in, if I go from -2 to 0, instead of typing in that great big function, I know we simplified it into something smaller, but if we hadn't, if I had left it the great big mess, really all I'm doing is taking my y1 function and minusing my y2 function. So there is, I was just there. If I do vars and I go over to y vars, under functions, I've got y1 right there. I can do y1 minus vars, y vars function. I've got y1 and I've got y2. And then if I need to add my integral from 0 to 2, this time I'm doing y2 minus y1. So I'm going to do vars function. I go down to y2 minus vars function y1. Oh, it's not going to work on my calculator. On your calculator, it'll work. You have a function that you've defined because you defined it right here, y1 and y2. Mine is not showing up. For some reason, it doesn't. This is what happens when you have the free version of it. It'll work on your calculator. Instead of putting in that whole big thing, you can just put in y sub 1, y sub 2, and it'll give you, where am I? Second, quit, get out of there. It'll give you the answer. I don't know why it doesn't connect in mine. Maybe I should actually pay for a version of this calculator. Anyway, there's a shortcut for you. I'll show you in class if you want to see how to actually do that on a regular calculator. All right? Okay, moving on. We are looking at what if our functions look a little bit different. For example, find the area of the region bounded by the graphs x equals 4 minus y squared and x equals y minus 2. Well, all of a sudden, these aren't y equals anymore. In fact, if I were to graph these two functions, if my 4 minus y squared is just an upside down parabola, but my axis is no longer the same, right? I switched my axis. So this is going to be shifted over 4, but it's going to go to the left like this because it's x equals negative y squared instead of y equals negative x squared. And then my x equals y minus 2, same thing. Instead of just x equals y and then shifting to the left, what would we have had? X equals y minus 2. So that would have actually shifted us down 2, and it would have looked like this. This time it's y minus 2. So it's the same image, but it's shifted to the left instead. Okay, so we're shifting over to the left too. So in this case, I have, I can't really find my top and the bottom change, right? Like if I look at my graph right here, something changes. Okay, here on the left, my x equals y minus 2, that graph is on top. But then when I get to the right of that, all of a sudden it becomes it's not on top all the way across. So one of the things that we can do, because we have, well, and I guess even more so than that, we've got this whole section right here that is in between those two, but it's not, it doesn't have an up and a bottom bound. okay? It goes up forever. It's not bounded. So basically what we're doing is we are going to turn, instead of, try to erase some of this, instead of using integrating with respect to x, we're going to integrate with respect to y. Now, when I do that, it gives us a hint right here that we are going to use the right curve first, and then we're going to minus the left curve. So when I take my integral, the curve to the right is my parabola. It's my 4 minus y squared. And then I'm going to subtract my y minus 2, and this time it's dy instead of dx. But I need to set these equal to each other, right? I need to find these intersecting points right here. I need to find where they're the same. So if I do 4 minus y squared is equal to y minus 2, I'm going to move everything over to the right. So I get 0 equals y squared plus y minus 6, which means that this is going to factor to be y plus 3 and y minus 2, which means my y's are going to be negative 3 and positive 2. So instead of going from x's, I'm using my y values from negative 3 to 2. So I keep turning this like, oh, look, you just turn it like on your paper. But when I turn it, the image doesn't turn for you. It just, it calibrates so that it's always facing up. But I don't think we've integrated with respect to y. This might be the first time that we've done that. So my integral is now right here. And I've found my endpoints. I found my integral. Now we just have to actually go through the work of doing it. So when I integrate with respect to y, well, let's just do it on the calculator. Again, this is probably not going to be a do-it-by-hand problem. If you were doing it by hand, you're going to end up with what? This is going to become 4y minus 1/3 y cubed. And then this negative y is going to become negative 1/2 y squared. And that positive 2 is going to become plus 2y. And those cancel out, and you end up with 6y minus 1/3 y cubed minus 1/2 y squared, evaluated from negative 3 to 2. So you could do that. You can do it by hand, plug in all the numbers, go through all the work. Or, guess what, guys? Our calculator doesn't know the difference between x's and y's. So on my calculator, if I go to math, integrate, I'm going to go from negative 3 to 2. And instead of putting a y dy, I'm going to keep using x's because it's just a variable. I know what it represents. It's not going to give me the wrong answer just because I'm using x instead of y. So I'm going to put in my calculator, negative x. What should I be putting in my calculator? Negative x squared minus y, or minus x, and then we're adding 6, right? If we had simplified everything, it'd be negative x squared minus x plus 6. So when I hit enter, what did I just do? Negative x squared minus x plus 6. I'm going from negative 3 to 2. Why is it not happy with me? It's still not happy with me. Maybe we have to, if it's using them as x's, x is just our variable, so that shouldn't be the problem that I'm getting. Did we put it in right? 4 plus 2, that's 6, negative y squared minus y dy. We're going from negative 3 to 2. So why am I getting a syntax error? Let's put it in one more time. Negative 3 to 2. Oh, because I did minus x squared. That's why. Negative x squared. I know what I did. Minus x. Sorry, guys. Plus 6. Going, this should be working just fine. There in front of the x squared at the beginning, I used a minus instead of a negative. It doesn't like it when you do that. So I get 20.8333333 forever. So 20.83 repeating is my approximate answer. All right. So again, on the test, you are going to get a point for finding our, where did we do it? We get 1 point right here for finding our endpoints. You're going to get another point for setting up the integral. And then you're going to get another point for getting the right answer, okay? Speaking of AP tests, we've got a couple of them right here. I don't think we'll do all of it. In fact, we'll probably save the next question to do in class. Yeah, we'll do the next one in class. We'll do this one right here. We'll do the next one together. So it wants us to find the area of R, and it tells us R is the region in the first and second quadrants bounded by the above graph, and the horizontal line y equals 2. So I have y equals 20 over 1 plus x squared and y equals 2. Okay, first thing that I need are endpoints, okay? Now this is question number 1, so I am allowed to use my calculator. So I can either set these equal to each other, 20 over 1 plus x squared equals 2, or I can graph them on the calculator and find where they intersect, okay? Either way, you graph them, you find that, well, maybe we should actually do it. I know it's a long video already, but let's do this right. So if I do alpha, let's put in a fraction, and I'm going to put in 20 over 1 plus x squared, I think. And then we're going to minus 2. And then nope, it's just 20 over x squared. And then I have y equals 2. When I graph that, let's do zoom standard, which is 6. I'm looking for my intersections, right? So I can use the intersection tool, and I find out that I'm intersecting at negative 2, and I'm also intersecting at positive 2, okay? So I know that x equals 2 and negative 2 are my intersections. So is that right? No, x is 3 and x is negative 3. Okay, that sounds better. You're going, wait, numbers aren't going to add up. X is 3 and negative 3. I was looking at the wrong number. Okay, so those are my endpoints, negative 3 to 3. So there's going to be 1 point on the test question. Then I set up my integral. So my top function, if you don't remember, look at it. My top function is the blue one. So that's my 20 over 1 plus x squared. And then I'm going to minus the bottom function, which is 2. And then I get my dx. So there's another point on the AP test if you write it down, okay? If you just go from this step here and then put it in the calculator and you don't show them what you put in the calculator, guys, you're not going to get the points, okay? So I'm going to go ahead and plug that in my calculator. Go back to, let's go to the main screen. Math, integrate, we're going from negative 3 to 3. And I've got, let's make a fraction, 20 divided by, 20 over 1 plus x squared. And then I'm going to minus 2. And Roman, I'm sorry, when you put that in the calculator, it's going to take a lot more steps for you to do it. But you end up with 37.962, approximately 37.961 or 37.962, because you can either trunk the problem or you can round it. Either way, you would have gotten the right answer, okay? So that would have given you a point. Yeah, Roman, when you put that one in, yours is going to be a mess because you're going to have to do parenthesis 20 divided by parenthesis 1 plus x squared parenthesis, and then you're going to have to minus 2. It's going to take a few extra steps for you there. Okay. Next AP question. Yeah, let's just do this one together in class. It's not really difficult. You can try it on your own, especially finding the area of R. You've got different bounds that you need to pay attention to. Part B is a little bit more complicated because you're having to find the area of S, which looks like it's just in between two horizontal lines, but your left and your right bounds aren't exact. So we'll work on that one in class. Just work on the homework a little bit at home if you can. Be ready to talk about this when I see you in class.